Hello. Today we're sitting here with an Ohio State soil scientist, Libby Dayton. Libby is in the School of Environment and Natural Resources amongst the cohort of soil scientists like myself. And I've asked Libby if she wouldn't mind talking a little bit about some of the work that she's been doing recently. And so just launch into it, ask you some questions about, you've been leading this effort to revise the Ohio P Risk Index, and that's a big lift. Tell us a little bit about what the Ohio P Risk Index is and why does it need revision?
Well, back in 1993, the USDA developed the concept of a P Risk Index, and it's supposed to, what the goal was that a P Risk Index would tell a farmer what the risk of phosphorus runoff is based on their field properties and their farmer management practices. So most states have adopted some sort of a P Risk Index. Ohio has had one, I think, since 2001, but it was never vetted with any data. And so there's always been a concern of whether or not it's functioning, and so that was why the interest came in to evaluate it and, as necessary, revise it.
Okay. So when Ohio, do we know enough about when Ohio, the first version of this index, was it kind of imported from another state, or was it kind of, was there data that was generated in Ohio that went into this index? Do you know?
There was no data generated in Ohio. It was sort of imported from Pennsylvania, but they didn't have a lot of data either. And a lot of the data was small plot data, or it was experimental data, but not field scale data. And so it's always been, it's been dubious.
Okay.
And so we that's how we set about to revise it.
Okay, great. So we're looking at kind of a best guess index and revising it to something that's actually a data-driven tool, right?
That was the attempt, and I think we've succeeded.
Okay, great. And that's a cut. No, I'm just kidding. Okay. So this is a high-profile research project in the college, at the university, at a state level. There's a lot of people, of course, we've already talked in the class quite a bit about phosphorus and water quality. It's not just phosphorus, of course, there's nitrogen pieces to this. Can you just tell us a little bit about who's all involved, who's got their finger in this project, and maybe who's funding it and who's interested in it?
Well, the project really, I got started with this back in 2007. I was fairly new in Ohio, but I was invited to serve on the Lake Erie Phosphorus Task Force. Okay. And so it was through that I realized that most people in the state weren't even aware that there is a P index in Ohio. And so we kind of started from there, and so that gave me the idea that the best thing we could do is upgrade the P index so it's actually functioning. So building partnerships from there is actually where it started. And so it was early on with Ohio Department of Ag. They introduced me to the Ohio Commodity Groups, which is the Ohio Soybean Council, Ohio Corn and Wheat. The Andersons has been a tremendous partner. The Farm Bureau, and then of course USDA Natural Resource Conservation Service. But those are probably the big players, and they've been very involved all the way through the process.
Okay, so you've got representation or buy-in, people that are wanting this work done, mostly from the farming community, the industry itself, and then also some agency groups, both at the state and federal level, right?
Because obviously the farming community feels a tremendous pressure because of the water quality issues, and there's a lot of frustration that this is going on, and there have been a lot of best management practices and implemented, and yet the problem still continues. And so that's what I think got the farming community really interested in participating in this. So it would be a really science and data-driven project. Great. And they've been great partners.
Okay, so anytime we talk about these large, complex environmental issues, there's usually a lot of people that are interested or have different opinions and voices, and I'm wondering if, for what it's worth, if you could share some of your experiences just in terms of trying to, manage those different voices, and if you have any kind of approach or thoughts or reflections in terms of thinking about what the ag industry wants versus the agencies versus what farmers want, or other local just regular landowners that might not be into agriculture. it's kind of a weighted question, maybe a hard question to answer, but how do you kind of manage all those pieces?
I think that you're right. There has been a lot of that, and the biggest issue is there's a lot of what I consider to be the mythology around this subject. There's a lot of misinformation, and then people get very emotional about, what they think is driving the problem, and so that causes a little bit of frustration. And so the only way that we've managed that really is we keep it simple, we try to keep the messaging simple, and we try to keep it really tight to the data. Okay. So I'm not saying my opinion, we're showing what the data says, and then we try to just keep a simple message, and that seems to be working pretty well in that people are coming around, or then they see where their concerns are in fact being addressed by the work that we're doing. So we try to show each of those groups how their concerns are in fact being addressed by the work we're doing as a holistic approach.
That's great. And of course communicating is key, right? It takes time to let people know what's going on, what you're finding,
yes,
providing feedback and reports,
yes,
but just making sure everyone's on the same page. And
I probably give 50 presentations a year just in Ohio, and I get invited, I get summoned to board meetings and different work groups and task forces, and we report out regularly. So yeah, the communication is an ongoing task.
And how long have you been really kind of knee deep in working on this project?
Well, the project first got funded in 2012. So it's been a while.
Over 5 years. So it's a lot of work you're talking about. It's a chunk of your career, really, and to think of it like that. Okay, so taking a step back, we'll say, okay, we're looking for tools to monitor nutrient loss from the field, in particular phosphorus, which we know is challenging to actually estimate. And so is this I'm just curious, who wants this? People, of course, there's sponsors that have paid money for that. Do they want that to regulate farmers, or do farmers want that? Who wants this information that this P-risk index is actually going to provide, or who's asking for that information in your opinion?
I think in my world the farmers are asking for it. The farmers, as I say, they feel like they're under pressure, they're under fire. And so they really want to understand their fields and their practices and what's happening on their farms. And so then they can see, well, I'm doing okay, or I could do some improvements. But they really have been, I think, the driver. Now the agencies need it because they're running programmatic things for concentrated animal feeding operations, for animal agriculture, for other conservation programs. And so they do use P-index behind the scenes for some of those programs. So they are interested in upgrading those programs. But really the driver has been the farmers. Okay,
so this is a great point. We haven't really talked about this in class at this point, but there are, when, Ohio Department of Ag, when they are permitting to allow farmers to essentially have these confined feeding operations, whether they be chickens or swine or beef in the state, they have to permit, and then part of that permitting process is developing a nutrient management plan, right?
Right.
And then part of that nutrient management plan, of course, you're bringing all this high concentrate nutrient in feed. It's getting processed for the animal. We all know what happens when it comes out the backside. So what happens to that manure, and how is that accounted for from a nutrient management perspective, right? So.
Right, and so from our standpoint, we have a one whole section of the tool is nutrient application, whether it be manure or fertilizer. Okay. And so then hopefully that's helpful to those program leaders and how they sit down and how they work with their farmers.
Great. Okay, so I'll just play devil's advocate and ask you a question. But what would be your response if somebody says, oh, you're trying to model P-loss? Well, just look at soil erosion, because particulate phosphorus total, that's lost with that soil particle is really what's driving phosphorus loss in the field. How would you respond to it?
I would say that's almost exactly right. And I would agree with a lot of that statement. And that's one of the mythologies that we've been kind of pushing back against a lot over the last 5 years, is that we keep hearing in the press and in a lot of the white papers and the policy papers that the risk driver is the dissolved P. But that's not what the data shows, and not just our data, but data across the Corn Belt for the last 50 years shows that a tremendous amount of the phosphorus is actually traveling with eroded soil. And so in our tool, we focus strongly on erosion. And it's not just erosion, but it's also, it's like how much eroded soil do you have, but then also how rich in phosphorus is that soil. So that brings in the soil test level. And so, yeah, I have no problem with that. What we've tried to do is quantify that loss so that we can tell a farmer how many ton per acre they may be losing in erosion, and then tie that to a pound per acre phosphorus estimate. And so that way it's not just saying, well, you've got quite a bit of erosion, but we can quantify. And then it gives the farmer the opportunity to test different scenarios, different farmer management scenarios, and see if they can reduce their erosion, and then that would reduce their P runoff. And so that's the power of the tool, is the power of being able to make those farmer management comparisons. If you have a very low soil test phosphorus, erosion still drives. It's still so it's a clearly important piece. So So talk to us a little bit just explain the differences when we talk about total P versus particulate P versus DRP or dissolved reactive phosphorus. What are those like? Just tell us a little bit about those three pieces in terms of what they are and what they make up, which ones are important, and what are you all measuring in the lab to do that? Yeah. So for those who aren't familiar with the project, we actually have edge of field monitoring at the edge of the field. So we have samplers collecting all the runoff from both the tile and the surface runoff. And so we go out every week, and we were going out every week during the project, and we collect bottles of muddy water. And so if you get all that muddy water into suspension and you take a sample and then you digest it in a strong acid, that gives you the total P in that runoff. So that's the total P. And then if you take a subsample of that and you filter it through a really fine, we use a 0.45 micrometer filter, that gives you the dissolved P. And so then total P minus dissolved P tells you how much was particulate bound. So those are the three fractions that we measure. We also measure the suspended sediment coming with the runoff, and then of course the runoff volume, because concentration times volume equals load.
Yes, we love that. We love that
so
formula.
That's the part.
Okay, great. And so, but we've been hearing from, at least we can say with certainty, in the coming out of the mouth of the Maumee River into Lake Erie, that total P over the years with conservation tillage and other management practices particulate P has been declining over the years, is that right? But DRP is on the rise, right?
Right.
Do we have any idea why that might be, or is it still kind of a lot of uncertainty in the science?
I think that, and again, we're a little outside my area, but I think that a lot of it is that the erosion. Back in the 1990s, there was a big program for reducing tillage, and then also to install buffer strips. And so I do think that the sediment load in the Maumee went down by, I think it was like 30%. So what that means is that the total P coming out the Maumee has gone down, and the proportion of particulate P has gone down relative to dissolved P. But what I always remind people as a soil scientist, and you know this, as soon as that eroded soil goes into the drainage ditch or goes into any waterway, the phosphorus is going to start dissolving out of it. So what may have started at the edge of field as particulate bound P, by the time it gets to the gauge station 50 miles away, a lot of that will now be in a dissolved form, just because of equilibrium.
Yeah, that's great.
And so that's what we remind farmers all the time, is the only thing we can ask the farmer to control is what's happening at the edge of their field. And so that's where we keep our focus.
But it's important, it just kind of underscores the complexity of the system, right? And that's exactly why you measure, it takes three times as long or maybe more to get all those measurements, but you need to do that so you have a better understanding what's happening in the system, right?
Right. Okay. It's very important.
Great. Okay, well, this is great, Libby. What else do you want to tell us that we haven't covered? Is there anything else that we...
Well, I think that the project has certainly been a lot of fun, and interacting with everybody around the state has been. I've learned a lot, and I've enjoyed that a lot because I'm not an agronomist, so I've learned a lot working with the farmers. And I think so. Our next big thing, I think, is going to be working on implementation of the tool, working with our partners, but to really drive implementation so that farmers can actually use the tool to their benefit. And we'll see how that goes.
Great. Okay. So yeah. So it's thinking about this from a start to finish perspective. It's identifying the need, building the team, and of course we all need funding to drive a lot. If we want to generate data, it costs money, and
especially field scale data.
And it's not cheap, right? Research isn't cheap, and so when we do that, we think about what that takes, and then of course it's not just developing the model and figuring that out, but then you've got to take all that data and you've taken it to the back end and had some pretty sophisticated programming to make it into a user-friendly tool, right? And so that's what kind of the next step is right now, right? So that's where you're at, where the tool is in beta form, and it's it's going to get released at some point and made public, made widely available for farmers to use if they need to use it.
Yes, and right now we're trying to solicit interest and cooperation, again, from our agency partners, primarily Soil Water Conservation District, NRCS, OSU Extension. And so we're hoping that we'll be training them on how to use the tool so that they can work with their farmer customers with the tool. And so that'll make it less frustrating, we hope, for the farmers.
Okay, great. All right, well, Libby, I really appreciate your time. Thanks for talking with us.
Appreciate your interest.
Okay.